Shipping software is easy. Proving that a release decision was based on the right evidence is much harder. ProofLatch turns a bounded evidence packet into a defensible decision. Deterministic code owns the verdict. GPT 5.6 explains it. Codex receives a bounded repair brief when work is required. Here is the bundled blocked example. The server applies its own policy and exact required checks. The client cannot rename them, remove them, or quietly make them optional. The result is blocked because authoritative checks are missing or failing. GPT adds a concise explanation and risk summary, but it cannot upgrade or downgrade that verdict, even if prompted. The receipt records the policy, evaluator version, supplied commit, deterministic assessment, and full digest. The digest binds those inputs after capture. It is not a signature or proof that commands actually ran. For Codex, ProofLatch produces a focused repair brief containing only the real blocking check IDs. That keeps the next coding turn narrow, auditable, and hard to misinterpret. For this demo, apply demo fix set is explicitly a simulated fixture swap. ProofLatch does not pretend it edited a repository. The changed evidence must be evaluated again. Now, every required check passes and the working tree is clean. The new evaluation is ready with a new digest and no model-created risks or repair steps. ProofLatch also ships as a token-free GitHub action. These are real hosted checks on the public repository, and protected main requires both ProofLatch and the full verification suite. ProofLatch makes a narrow, useful promise. Machine-enforced release truth stays separate from model explanation, and the decision becomes a reproducible receipt. The app, action, and source are public.